This is the EdExcel A-Level Maths Paper 2 from the 2023 series. Question number 1. f of x is equal to x cubed plus 2x squared subtract 8x plus 5. For part A, we have to find f double dash of x. With part A, we are given f of x as shown here. To find f double dash of x, we are required to differentiate f of x twice. If we differentiate f of x once, we end up with the first derivative, f dash of x, and differentiating each term. Differentiating the x cubed, we end up with 3x squared. Differentiating the 2x squared, we end up with 4x. Differentiating the negative 8x, we end up with negative 8, and differentiating the 5, we end up with 0. If we differentiate f dash of x, we end up with the second derivative, f double dash of x. And if I differentiate each term, differentiating the 3x squared, we end up with 6x. Differentiating the 4x, we end up with 4. And differentiating the negative 8, we end up with 0. So f double dash of x, the second derivative, is equal to 6x plus 4. Part B, for the first part, we have to solve f double dash of x equals 0. If we set f double dash of x equal to 0, we have the 6x plus the 4 equaling 0. And if I solve for x, you will find x to equal negative 2/3. For the second part of part B, let's find the range of values of x for which f of x is concave. For the second part of part B, the curve is concave when f double dash of x is less than 0. We have found in the first part of part B a critical value of x equals negative 2/3. So the curve will be concave when x is less than 2/3. Question 2. A sequence u1, u2, u3, etc. is defined by u1 equals 35, un plus 1 is equal to un plus 7 multiplied by the cosine of n pi over 2, subtract 5 multiplied by negative 1 to the n. For part A, for the first part, we have to show that u2 is equal to 40. For the first part, we are given that u1 is 35. u2, that will equal u1 plus 7 times by the cosine of 1 pi over 2, subtract 5 multiplied by negative 1 to the power of 1. We know what u1 is, that's 35, so u2 is equal to 35 plus 7 times by the cosine of pi over 2, subtract 5 multiplied by negative 1 to the 1. And if we work this out, we have 35 plus 7 times by the cosine of pi over 2, subtract 5 multiplied by negative 1 to the power of 1, and it turns out u2 is equal to 40. We now have to find the value of u3 and the value of u4. The value of u3, that's equal to u2 plus 7 times by the cosine of 2 pi over 2, subtract 5 multiplied by negative 1 to the power of 2. We know what u2 is, that's 40, so we have 40 plus 7 times by the cosine of 2 pi over 2, subtract 5 multiplied by negative 1 squared. So if we work this out, we have 40 plus 7 times by the cosine of 2 pi over 2 subtract 5 multiplied by -1 squared. And if we work this out, you will find u3 to equal 28. u4, that's equal to u3 plus 7 times by the cosine of 3 pi over 2 subtract 5 multiplied by -1 to the power of 3. We know what u3 is, that's 28, so we have 28 plus 7 times by the cosine of 3 pi over 2 subtract 5 multiplied by -1 cubed. So if we work this out, we have 28 plus 7 times by the cosine of 3 pi over 2 subtract 5 multiplied by -1 cubed. And it turns out u4 is equal to 33. Given that the sequence is periodic with order 4, for the first part of part B we have to write down the value of u5. Well, if we know that the sequence is periodic with order 4, that means u5 is equal to u1. And we know what u1 is. That's 35, which means u5 is equal to 35. For the second part of part B, we have to find the value of the sum from r equals 1 to r equals 25 of ur. So, the sum from r equals 1 to r equals 25 of ur, well, we have u1 plus u2 plus u3 plus u4, and then we can continue this till the final couple of terms. For the final couple of terms, we have u24 plus u25. Now we know that the sequence is periodic with order 4. And if we think about what that actually means, we've got u1 which is equal to u5, u2 which is equal to u6, u3 which is equal to u7, u4 which is equal to u8, which means for the first 24 terms, the terms from u1 to u4 are repeating 6 times. So we have 6 multiplied by u1 plus u2 plus u3 plus u4, and this will give us the first 24 terms, and then we add on u25. We know what u1, u2, u3 and u4 are, so we have 6 multiplied by 35 plus 40 plus 28 plus 33 plus 35. And if we work this out, 6 multiplied by 35 plus 40 plus 28 plus 33 plus 35, that gives us 851. So the sum from r equals 1 to r equals 25 of ur is equal to 851. Question number 3. Given that log base 2 of x plus 3 plus log base 2 of x plus 10 is equal to 2 plus 2 times log base 2 of x, for part A we have to show that 3x squared subtract 13x subtract 30 equals 0. For part A, we begin with log base 2 of x plus 3 plus log base 2 of x plus 10 equals 2 plus 2 times log base 2 of x. Now let's leave the left hand side alone, but on the right hand side we can rewrite the 2 as log base 2 of 4, and using the power law of logs we can write 2 times log base 2 of x as log base 2 of x squared. Now each term in this equation is in terms of log base 2. So now what we can do is use the addition law of logs to simplify both the left hand side and the right hand side. if we simplify the left-hand side using the addition law of logs, we would have log base 2 of x plus 3 times x plus 10, and on the right-hand side, we would have log base 2 of 4x squared. And if we anti-log both sides of this equation, we will be left with x plus 3 times x plus 10 equals 4x squared. If I expand the brackets on the left-hand side, we will end up with x squared plus 13x plus 30, and on the right-hand side, we have the 4x squared. And if I rearrange this equation, well, we have 4x squared subtract x squared, that's 3x squared, and then we have the 0x subtract the 13x, which will give negative 13x, and then we will have 0 subtract 30, which is negative 30, and this is equal to 0. And this is the result we wanted to show. 3x squared subtract 13x subtract 30 equals 0. For the first part of part B, we have to write down the roots of the equation 3x squared subtract 13x subtract 30 equals 0. We are required to solve this equation. So if we go to the equation sub-menu, we have a polynomial of degree 2. We have 3x squared subtract 13x subtract 30 equals 0, in which case you will find one of our solutions is x equals 6, the other solution is x equals negative 5 over 3. For the second part of part B, then state which of the roots in part Bi is not a solution of log base 2 of x plus 3 plus log base 2 of x plus 10 equals 2 plus 2 times log base 2 of x, giving a reason for your answer. Well, if I think about this log base 2 of x, and if I also think about the solutions I have here, well, the x equals negative 5 over 3, that will not be a solution, and that's because log base 2 of x is not defined for this value of x, which means x equals 6 is our only solution for x. Question number 4. Coffee is poured into a cup. The temperature of the coffee, H degrees C, t minutes after being poured into the cup is modelled by the equation H equals ae to the negative bt plus 30, where a and b are constants. Initially, the temperature of the coffee was 85 degrees C. For part A, we have to state the value of A. For part A, we are given a condition that when t equals 0, H is equal to 85. And if we substitute these into our equation, we have 85 equals A multiplied by e to the 0 plus 30. And e to the 0 is just 1. So we have the value of A equaling 55, which means H is equal to 55 e to the negative bt plus 30. Initially, the coffee was cooling at a rate of 7.5 degrees per minute. For part B, we have to find a complete equation linking H and T, giving the value of B to 3 decimal places. So, we need to first of all find out what dH over dt is, because we are considering the rate of cooling. dH over dt, if we differentiate, we end up with negative 55b e to the negative bt. We also have this condition that when t equals 0, dH over dt is equal to negative 7.5. The reason t is equal to 0 is because we are concerned with the initial cooling rate, and because we are cooling the coffee, we have this negative. So dH over dt is equal to negative 7.5. So if we substitute these back into the differential equation, we have negative 7.5 equals negative 55b e to the 0. And if we attempt to solve for b, we have negative 7.5 over negative 55, which as a decimal is 0.136, etc. So to 3 decimal places, we have b equaling 0.136. We can now write down the complete equation for h. We know what b is, so replacing b with 0.136, h is equal to 55e to the negative 0.136t plus 30. Question number 5. The curve C has equation y equals f of x. The curve passes through the point P with coordinates 3, negative 10, and it's got a turning point at P. We're given that dy over dx is equal to 2x cubed subtract 9x squared plus 5x plus k, where k is a constant. For part A, we have to show that k is equal to 12. We know for part A that we've got a turning point at P. Now P has an x coordinate of 3, and because we've got a turning point, dy over dx is equal to 0. So when x is 3, dy over dx equals 0. Let's substitute this into dy over dx. So we have 2 times 3 cubed, subtract 9 times 3 squared, plus 5 times 3 plus k. This is equal to 0. And if we simplify this, we end up with k subtract 12 equals 0, in which case you can see k is 12. And now that we know what k is, we can conclude dy over dx is equal to 2x cubed subtract 9x squared plus 5x plus 12. For part B, hence find the coordinates of the point where C crosses the y-axis. To find out where C crosses the y-axis, we need our function f of x. And to find out what f of x is, we would have to integrate dy over dx. So, for part B, y is found by integrating dy over dx, so y is equal to the integral of 2x cubed subtract 9x squared plus 5x plus 12 with respect to x. And if we integrate each term, integrating the 2x cubed, we end up with x to the 4 over 2. Integrating negative 9x squared, we end up with negative 3x cubed. Integrating 5x, we end up with 5x squared over 2. And integrating the 12, we end up with 12x. And then we add on a constant c. We know that the curve passes through the point P with x coordinate 3 and y coordinate negative 10. So when x is 3, y is negative 10, and if we substitute these into y, we have 3 to the 4 over 2, subtract 3 times 3 cubed, plus 5 times 3 squared over 2, plus 12 times by 3, plus c. This is equal to negative 10. And if we simplify this, you will find c plus 18 to equal negative 10, in which case c is equal to negative 28. And if c is equal to negative 28, that means y is equal to x to the 4 over 2, subtract 3x cubed plus 5x squared over 2 plus 12x, subtract 28, which means then c crosses the y-axis at negative 28. Question number 6. Relative to a fixed origin O, A is the point with position vector 12i, B is the point with position vector 16j, C is the point with position vector 50i plus 136j, D is the point with position vector 22i plus 24j. Part A, show that AD is parallel to BC. To begin with, for part A, we have the vector AD, which is equal to the vector OD subtract the vector OA. So we have the vector OD, which is 22i plus 24j, and we subtract from this the vector OA, which is 12i plus 0j. And working this out, we end up with 10i plus 24j. And if I work out the vector BC, that's equal to the vector OC subtract the vector OB. So we have the vector OC, which is 50i plus 136j, and we subtract from this the vector OB, which is 0i plus 16j. And working this out, we end up with 50i plus 120j. Now we want to show that AD is parallel to BC, so I need to compare the 10i plus 24j with the 50i plus 120j. And what we can do with this vector BC is factorize out a 5, and if I factorize out a 5, what we'd have is 5 multiplied by 10i plus 24j. So what you can see here then is BC is 5 times greater than the vector AD. So because BC is equal to 5 multiplied by AD, we can conclude that the vectors are parallel. Points A, B, C and D are used to model the vertices of a running track in the shape of a quadrilateral. Runners complete one lap by running along all 4 sides of the track. The lengths of the sides are measured in meters. Given that a particular runner takes exactly 5 minutes to complete 2 laps, you have to calculate the average speed of this runner, giving the answer in kilometers per hour. We begin part B with a diagram. We've got the points A, B, C and D as we see here. And with this we can work out various vectors. We've got the vector AB, which is 12i plus 16j. The vector BC, starting at B, finishing at C, that's 50i plus 120j. We can now work out the vector CD, starting at C, finishing at D, that's negative 28i, subtract 112j. And the vector AD, that's given by 10i plus 24j. Now that we know what all these vectors are, we can work out the lengths of each of these sides. So let's begin with AB. Working out the length of AB, we have 12 squared plus 16 squared square rooted, which is 20. Let's work out the length of BC. We have the square root of 50 squared plus 120 squared, which is 130. Let's work out what CD is. We have the square root of 28 squared plus 112 squared, which is 28 times square root 17. And working out the length of AD, that's equal to the square root of 10 squared plus 24 squared, which is 26. So with this, what we can now do is find out the total length of 2 laps. So we have 2, because we've got 2 laps, multiplied by the 20 plus the 130 plus the 28 root 17 plus the 26. So if we work this out, we have 2 multiplied by 20 plus 130 plus 28 times the square root of 17 plus the 26, and it turns out the total length of the 2 laps is 582.89, etc. So for the average speed, we have the distance 582.89 etc. meters divided by 5/60 of an hour. And the reason we have 5/60 is because we are going from minutes to hours. So if I divide this by 5 over 60, we end up with 6,994.7 etc. meters per hour. We want this to be in kilometers per hour, so I need to divide this by 1,000, leaving me with 6.99 kilometers per hour to 3 significant figures. So the average speed of this runner is 6.99 kilometers per hour. Question number 7. A curve has equation x cubed plus 2xy plus 3y squared equals 47. Part A, we have to find dy over dx in terms of x and y. To begin with, we have our curve x cubed plus 2xy plus 3y squared equals 47. And for us to find out what dy over dx is, we have to differentiate each term. And notice we have a mixture of x's and y's, which means we have to differentiate implicitly. So if I differentiate the x cubed, I end up with 3x squared. If I differentiate the 2xy, well, here I'd have to use the product rule. We have the 2x multiplied by the derivative of y, which is dy over dx. Let me add on to this y multiplied by the derivative of 2x with respect to x, which is 2. And then we add on to this the derivative of 3y squared with respect to x, which is given by 6y multiplied by dy over dx. And on the right hand side, the derivative of 47 is just 0. Now, with the 2x times dy over dx and the 6y times dy over dx, we can factorise out a dy over dx. And inside the bracket we'd have the 2x plus the 6y. And if I take the 3x squared and the 2y to the right hand side, on the right hand side we have negative 3x squared subtract 2y. And if I divide both sides by 2x plus 6y, we can therefore conclude dy over dx is equal to negative 3x squared subtract 2y over 2x plus 6y. The point P with coordinates negative 2, 5 lies on the curve. For part B, we have to find the equation of the normal to the curve at P, giving an answer in the form ax plus by plus c equals 0, where a, b and c are integers to be found. For part B, we have this point P with coordinates negative 2, 5. With this we can find the gradient of the tangent by substituting the x coordinate of negative 2 and the y coordinate of 5 into dy over dx. So if we do that, dy over dx, that's equal to negative 3 multiplied by negative 2 squared subtract 2 multiplied by 5 over 2 multiplied by the negative 2 plus 6 multiplied by the 5. And if we work this out, we get negative 11 over 13, which is the gradient of the tangent. So the gradient of the normal is the negative reciprocal of this, which is 13 over 11. So therefore, we have y subtract 5 equals 13 over 11 multiplied by x subtract negative 2. And if I multiply through by 11, on the left hand side we have 11y subtract 55, and on the right hand side, if I multiply the 13 into the bracket and recognizing that x subtract negative 2 is x plus 2, on the right hand side we would have 13x plus 26. And if I rearrange, you will find 13x subtract 11y plus 81 equals 0, in which case a is 13, b is negative 11, and c is 81. Question number 8, part A. We have to express 2 cos theta plus 8 sin theta in the form r cos of theta minus alpha, where r and alpha are constants. R is greater than 0, alpha is in between 0 and pi over 2. We have to give the exact value of r and give the value of alpha in radians to 3 decimal places. For part A, we begin with 2 cos theta plus 8 sin theta being equivalent to r times by the cosine of theta minus alpha. We can use the double angle formula to rewrite the right hand side. Cos of a minus b is equal to cos a cos b plus sin a sin b, which means we can rewrite the right hand side as the following. We have r cos theta cos alpha plus r sin theta sin alpha. And if we compare the cos thetas, well, on the left hand side we have 2 cos theta. On the right hand side we have r cos theta cos alpha, which means 2 is equal to r cos alpha. And if we compare these sin thetas, on the left hand side we have 8 sin theta, and on the right hand side we have r sin theta sin alpha, which means we have 8 equals r sin alpha. We can find the value of r. R is equal to the square root of 2 squared plus 8 squared, and if we work this out we get 2 times the square root of 17. And therefore what we can now do is find out what alpha is. If we divide this second equation by this first equation, we can find out what tan alpha is. Tan alpha is therefore equal to 8 divided by 2, from which we can find out what alpha is. We have the inverse tangent of 8 over 2, which is 1.325 etc., which means alpha is equal to 1.326 to 3 decimal places. Now that we know what r is and what alpha is, we can therefore conclude 2 cos theta plus 8 sin theta is equivalent to 2 times square root 17 multiplied by the cosine of theta minus 1.326 radians. The first 3 terms of an arithmetic sequence are cos x plus sin x, cos x plus 2 sin x, where x doesn't equal n pi. Given that S9 represents the sum of the first 9 terms of this sequence as x varies, for the first part of part B we have to find the exact maximum value of S9. Now we have an arithmetic series. The sum of the first n terms is given by a half n multiplied by 2a plus n minus 1 d, where a is the first term and d is the common difference. You can see our first term is cos x, and if we go from cos x to cos x plus sin x, and then cos x plus sin x to cos x plus 2 sin x, you can see the common difference is sin x. And we have 9 terms which we are adding, which means a is equal to cos x, d is equal to sin x, and n is equal to 9. And if we substitute these into the formula, Sn equals a half n multiplied by 2a plus n minus 1 d, then we have S9 equals a half multiplied by 9 multiplied by 2 multiplied by cos x plus 9 minus 1 multiplied by sin x. So if we tidy this up, we have a half times 9, which is 9 over 2, and then here we have 2 cos x plus 8 sin x. And what we found in part A is 2 cos theta plus 8 sin theta is equivalent to 2 times square root 17 times by the cosine of theta minus 1.326. And so if we use that, we have 9 over 2 multiplied by 2 times square root 17 times cosine of x minus 1.326. So 9 over 2 times 2 square root 17 is 9 times square root 17, and we multiply this by the cosine of x minus 1.326. And so therefore we can deduce that the maximum of this is 9 times the square root of 17. We now have to deduce the smallest positive value of x at which this maximum value of S9 occurs. This maximum occurs when the cosine of x subtract 1.326 is equal to 1. Which means, if I take the inverse cosine of both sides, the inverse cosine of 1 is 0, which means x subtract 1.326 is equal to 0, which means x is equal to 1.326. Question number 9. The curve C has parametric equations x equals t squared plus 6t subtract 16 and y equals 6 times the natural log of t plus 3, where t is greater than negative 3. Part A, show that a Cartesian equation for C is y equals a times the natural log of x plus b, where x is greater than negative b, where a and b are integers to be found. Part A, we have x equals t squared plus 6t subtract 16. We have y equals 6 times the natural log of t plus 3. And we want y in terms of x. So we begin with y equals 6 times the natural log of t plus 3. And this 6 we can rewrite as 3 times by 2. So we have 3 times by 2 times the natural log of t plus 3. And if I use the power law of logs, what this is equal to is 3 times the natural log of t plus 3 squared. So I have 3 times the natural log of, well, if I work out t plus 3 squared, I end up with t squared plus 6t plus 9. Now I want this to be in terms of x. So I've got 3 times the natural log of, well, I know what x is, that's t squared plus 6t minus 16. Here I've got a t squared plus 6t, so I can adjust with my constants to end up with an argument involving x. So I have t squared plus 6t subtract 16, and then I need to add on the 25 because the negative 16 and the 25 give the 9. So I have 3 times the natural log of x, because that's what t squared plus 6t subtract 16 is, plus this 25, which means a is 3 and b is 25. The curve C cuts the y-axis at the point P. We have to show that the equation of the tangent to C at P can be written in the form ax plus by equals c times the natural log of 5, where a, b and c are integers to be found. Now because we are required to find the equation of the tangent, what we need to begin with is dy over dx. So we know for part B, if y is equal to 3 times the natural log of x plus 25, dy over dx is equal to 3 over x plus 25. Now we know that the curve crosses the y-axis at the point P, and if it crosses the y-axis, we are considering what happens when x is equal to 0. And when x is equal to 0, y is equal to 3 times by the natural log of 25, which I can rewrite as 3 times the natural log of 5 squared, which is equal to 6 times the natural log of 5. I can also find out what dy over dx is when x is 0. That will equal 3 over 25. So we have our gradient of the tangent, which is 3 over 25. We've got x equals 0 and y equals 6 times the natural log of 5. So we have y subtract 6 times the natural log of 5 equals 3 over 25 multiplied by x subtract 0. And if I multiply through by 25, we end up with 25y subtract 150 times the natural log of 5 equals 3 multiplied by x, which is just 3x. And if I rearrange, you will see that 3x subtract 25y is equal to negative 150, which means A is 3, B is negative 25, and C is negative 150. Question number 10. F of x is equal to 3kx subtract 18 over x plus 4 multiplied by x subtract 2, where k is a positive constant. For part A, we have to express f of x in partial fractions in terms of k. So for part A, we have f of x given as 3kx subtract 18 over x plus 4 multiplied by x subtract 2. And if we were to express this using partial fractions, then this will be equivalent to a over x plus 4 plus b over x subtract 2. And we need to determine the value of a and the value of b. And if I multiply through by x plus 4 times x subtract 2, on the left hand side we have 3kx subtract 18, and on the right hand side we have a multiplied by x subtract 2 plus b multiplied by x plus 4. If I substitute in x equals 2, on the right hand side the a term disappears, and on the left hand side we have 3 times k times 2 subtract 18, which is 6k subtract 18, and on the right hand side we have b times by 2 plus 4, so that's 6b, and if I divide through by 6, b is equal to k subtract 3. And when x is equal to negative 4, the b term disappears. On the left hand side we have 3 times k times negative 4 subtract 18, so we have negative 12k subtract 18, and on the right hand side we have a multiplied by negative 4 subtract 2, which is negative 6a. And if I divide through by 6, noticing that the negatives cancel on the left hand side and the right hand side, we end up with a equals 2k plus 3, another value of a, another value of b, and I can replace a with 2k plus 3, I can replace b with k subtract 3. So I can conclude then that 3kx subtract 18 over x plus 4 multiplied by x subtract 2, that's equivalent to 2k plus 3 over x plus 4 plus k subtract 3 over k subtract 2. Which means f of x is equal to 2k plus 3 over x plus 4 plus k subtract 3 over x subtract 2. Part B, hence find the exact value of k for which the integral from negative 3 to 1 of f of x with respect to x is equal to 21. So for part B, we've got the integral from negative 3 to 1 of 3kx subtract 18 over x plus 4 times x subtract 2 with respect to x. And if I replace the integrand with 2k plus 3 over x plus 4 plus k subtract 3 over x subtract 2, we end up with the following. We have the integral from negative 3 to 1 of 2k plus 3 over x plus 4 plus k subtract 3 over x subtract 2 with respect to x. So let's evaluate this. Well, if I integrate 2k plus 3 over x plus 4, I end up with 2k plus 3 times the natural log of the absolute value of x plus 4. And if I integrate k subtract 3 over x subtract 2, I end up with k subtract 3 multiplied by the natural log of the absolute value of x subtract 2. And I'm evaluating this between negative 3 and 1. So if I substitute 1 in for my upper limit, I have 2k plus 3 multiplied by the natural log of 5 plus k subtract 3 multiplied by the natural log of the mod of negative 1. And then I subtract from this. Well, if I substitute in for my lower limit, we have 2k plus 3 multiplied by the natural log of 1 plus k subtract 3 multiplied by the natural log of negative 5. So let's simplify this. Well, I've got 2k plus 3 times the natural log of 5, and then noticing that the mod of negative 1 is just 1, I add on k subtract 3 times the natural log of 1, and then I subtract from this 2k plus 3 times the natural log of 1, and recognising that the mod of negative 5 is just 5, we add on k subtract 3 multiplied by the natural log of 5. So this is what we need to evaluate. So if we work this out and recognizing that the natural log of 1 is just 0, we have 2k plus 3 times the natural log of 5, subtract k subtract 3 times the natural log of 5. And if I factorize out a natural log of 5 from both these, well, I've got 2k subtract k, which is just k, and then I've got 3 subtract negative 3, which is 6. So I have k plus 6 times the natural log of 5. And I know that this will equal 21, because the integral is equal to 21. And if I solve for k, you will find k to equal negative 6 plus 21 over the natural log of 5. Question number 11. The tank is the shape of a cuboid being filled with water. The base of the tank measures 20 meters by 10 meters and the height of the tank is 5 meters, as shown in figure 1. At time t minutes, after water started flowing into the tank, the height of the water was h meters and the volume of water in the tank was v meters cubed. In a model of this situation, the sides of the tank have negligible thickness. The rate of change of v is inversely proportional to the square root of h. For part A, we have to show that dh over dt equals lambda over the square root of h, where lambda is a constant. So for part A, the volume of water v, that's given by 20 times 10 times h, which is 200 h meters cubed. So therefore, dv over dh is equal to 200. We can now find out what dv over dt is. We know from the question that the rate of change of v is inversely proportional to the square root of h, meaning dv over dt is equal to k over the square root of h. What we are required to find is dh over dt, and using the chain rule, that's equal to dh over dv multiplied by dv over dt. It's as though the dv's cancel. So I know what dh over dv is. That's 1 over 200, the inverse of dv over dh, and dv over dt is k over the square root of h. So what this is equal to then is lambda over the square root of h, where lambda is equal to k over 200. And that's what we wanted to show. Given that initially the height of the water in the tank was 1.44 meters, and exactly 8 minutes after water started flowing into the tank, the height of the water was 3.24 meters, we have to use the model to find an equation linking h with t, giving an answer in the form h to the 3 over 2 equals at plus b, where a and b are constants to be found. We have our differential equation dh over dt equals lambda over the square root of h. If I separate the variables, I've got the integral of the square root of h with respect to h equaling the integral of lambda with respect to t. Now I can rewrite this as the integral of h to the 1/2 with respect to h equaling the integral of lambda with respect to t. So integrating h to the 3/2, we end up with 2h to the 3 over 2 over 3, and integrating lambda with respect to t, we end up with lambda t. Don't forget we add on plus c as our constant. Now we are given that when t is 0, h is equal to 1.44, and if we substitute this in, we have 2 multiplied by h, which is 1.44, to the 3 over 2 divided by 3. This is equal to lambda times by 0, which is just 0, plus c. And if I work out what c is, I get c equals 144 over 125. And knowing what h is, we can therefore say that we have 2h to the 3 over 2 over 3 equals lambda t plus c, which is 144 over 125. So we also have this other condition that when t equals 8, h equals 3.4, and if I substitute this in, I have 2 times by 3.24 to the 3 over 2 divided by 3 plus 8 lambda plus 144 over 125. So I've got 486 over 125 equals 8 lambda plus 144 over 125. And if I solve for lambda, I get 171 over 500. And knowing what lambda is, I can therefore conclude that 2h to the 3 over 2 over 3 equals 171t over 500, plus 144 over 125. And if I multiply both sides by 3 over 2, we end up with h to the 3 over 2 equals 513t over 1000 plus 216 over 125. Part C, hence find the time taken from when water started flowing into the tank for the tank to be completely full. So for part C, let's see what happens when h is 5. If I replace the h with 5, I have 5 to the 3 over 2 equals 513t over 1000 plus 216 over 125. Let's find out what t is. I have 5 to the 3 over 2. Then I subtract from this 216 over 125. And then I divide this by 0.513. So it turns out t is 18.4 minutes. Question number 12. The number of subscribers to 2 different music streaming companies is being monitored. The number of subscribers NA in thousands to company A is modelled by the equation NA equals the mod of t subtract 3 plus 4, where t is greater than or equal to 0, where t is the time in years since monitoring began. The number of subscribers NB in thousands to company B is modelled by the equation NB equals 8 subtract the mod of 2t subtract 6, where t is greater than or equal to 0. T is the time in years since monitoring began. Figure 2 shows a sketch of the graph of NA and the graph of NB over a 5-year period. And that's what we see here. We have NA and NB all shown in this graph. We have to use the equations of the models to answer parts A, B, C and D. Part A, find the initial difference between the number of subscribers to company A and the number of subscribers to company B. So for part A, we are given what NA is and what NB is. Now because we are looking at the initial difference, we need to think about what happens when t is 0. And when t is 0, NA that's equal to mod of negative 3 plus 4, which is 7, so NA is 7. And when t equals 0, NB is equal to 8 subtract the mod of negative 6, so we have 8 subtract 6, which is 2. So NB is 2. And you can see those initial values plotted in figure 2. So when we talk about the difference, remember, N is in thousands. So 7 take away 2 is 5, but because we're in thousands, the difference will be 5,000. When t equals t, company A reduced its subscription prices and the number of subscribers increased. You have to suggest a value for t, giving a reason for your answer. What's happening with NA is at some point when t equals t, the number of subscribers is increasing, and that's at this point here. You can think of this point to be a minimum. Here we have the mod of t subtract 3 plus 4. The minimum therefore has coordinates 3, 4, which means then t is equal to 3. And that's because where we have t equals 3, that's where we have a minimum value of NA occurring. Part C, find the range of values of t for which NA is greater than NB, giving your answer in set notation. So for part C, we have NA being greater than NB. So we have NA, which is given by the mod of t subtract 3 plus 4, and that's greater than NB, which is given by 8 subtract the mod of 2t subtract 6. Now to solve this inequality, we need to replace the modulus signs with plus minus. So we have plus minus t subtract 3 plus this 4 being greater than 8 subtract plus minus 2t subtract 6. Let's deal with the positive. We have positive t subtract 3, which is t subtract 3, and then we add on the 4, and then we have this being greater than 8. Now here we have subtract a positive, so that's just the same as subtracting. So we're subtracting from this 2t subtract 6. So we subtract 2t and then add 6 because we've got the minus and the minus giving us a plus. So if we simplify this, I would have 3t being greater than 13, which means t is greater than 13 over 3. And that's shown here. Now if I deal with the negative, I've got negative t subtract 3, which is 3 subtract t. Then I add on the 4, and this is greater than 8. Now here I have negative and a negative, which is positive, so I'm adding on 2t subtract 6. So I have 5 being greater than 3t, which means t is less than 5 over 3. And if I show this in my diagram, I have the 5 over 3 here. Now I am looking where NA is greater than NB, and NA is greater than NB when t is less than 5 over 3 or greater than the 13 over 3. And that's what our solutions showed. We have to give our solution in set notation, which means we have t belonging to a set of real numbers where t is less than 5 over 3, or t belonging to a set of real numbers where t is greater than 13 over 3. Part D, we have to state a limitation of the model used for company B. Now if we think about what's happening after t equals 3, the number of subscribers for B, we assume, will continuously decrease. So the model shows the number of subscribers for B decreasing indefinitely. Now when t equals 7, for NB we have 8 subtract the mod of 2 times by 7 subtract 6, which is 0. So it crosses the t-axis when t equals 7, but beyond the 7 would have negative values of n. So for values of t greater than 7, we would have negative subscribers, which is not possible. Question number 13, part A. We have to find the first 3 terms in ascending powers of x of the binomial expansion of 3 plus x to the negative 2, writing each term in its simplest form. For a binomial series, we have the following result. Notice we have a 1 plus x to the n. Instead of a 1, what we have is a 3 instead. So for part A, if we have 3 plus x to the negative 2, what we can do is factorize out a 3 from both terms, so we have 3 multiplied by 1 plus x over 3. This will simplify to give the 3 plus x. And then we're going to raise all this to the power of negative 2. And using the laws of indices then, we have 3 to the negative 2 multiplied by 1 plus x over 3 to the negative 2. Now 3 to the negative 2, that's just a ninth. So we have a ninth multiplied by 1 plus x over 3 to the negative 2. And working out the expansion of this then becomes quite easy. So we've got the 1/9. Our first term will be 1. And for the next term, we have the negative 2 multiplied by the x over 3. And we divide this by 1 factorial. For our next term, we have the negative 2 multiplied by negative 2 subtract 1, which is negative 3, multiplied by x over 3 squared, divided by 2 factorial, and then we have higher order terms. So let's try to simplify this as much as possible. We've got 1/9 multiplied by 1, and here we've got negative 2 times by x over 3, so that's negative 2x over 3, and here we've got 6 times by a ninth divided by 2, so that will give us x squared over 3. And then we've got the higher order terms. And if I multiply the 1/9 into the bracket, I've got a ninth times 1, which is a ninth times negative 2x over 3, which is negative 2x over 27, and x squared over 3 times a ninth is x squared over 27. we are only required to find the first three terms, as we see here. Part B, use the answer to Part A and using algebraic integration, estimate the value of the integral of 6x over 3 plus x squared with respect to x between 0.2 and 0.4 to four significant figures. So for Part B, we have to estimate the value of this integral. Now what this is equivalent to is the integral from 0.2 to 0.4 of 6x multiplied by 3 plus x to the negative 2 with respect to x. And we've already worked out what the expansion of 3 plus x to the negative 2 is. That was found in Part A as a ninth subtract 2x over 27 plus x squared over 27. So what this is equivalent to is the integral from 0.2 to 0.4 of 6x multiplied by a ninth subtract 2x over 27 plus x squared over 27 with respect to x. And now if I multiply 6x by each of these terms in the bracket, well, 6x times a ninth, that's 2x over 3. 6x times negative 2x over 27, that's negative 4x squared over 9. And 6x times x squared over 27, that's 2x cubed over 9. So now we can integrate each term. So integrating 2x over 3, we end up with x squared over 3. Integrating negative 4x squared over 9, we end up with negative 4x cubed over 27. Integrating 2x cubed over 9, we end up with x to the 4 over 18. And this is going to be evaluated between 0.2 and 0.4. So if I work out what this is equal to, for our upper limit we've got 0.4 squared over 3 subtract 4 times 0.4 cubed over 27 plus 0.4 to the 4 over 18. So we get a value of 0.04527, etc. And we subtract from this our lower limit. For our lower limit, instead of us having a 0.4, we would have a 0.2 instead. And that gives us 0.012237, etc. So if I work out the difference between these, we end up with 0.03304 to four significant figures. Part C, we have to find using algebraic integration the exact value of the integral from 0.2 to 0.4 of 6x over 3 plus x squared with respect to x, giving your answer in the form a times the natural log of b plus c, where a, b and c are constants to be found. Well, we have this integral which we can rewrite as the integral from 0.2 to 0.4 of 6x multiplied by 3 plus x to the negative 2 with respect to x. We have a variety of options to use when integrating this. One method which we could use is integration by parts, and the formula for that is shown here. So, if I let u equal 6x, that means u dash is 6, and if I let v dash equal 3 plus x to the negative 2, that means v equals negative 3 plus x to the negative 1. So, what this integral is equal to is, well, I've got u times by v subtract the integral of v times by u dash, so that's negative 6 times by 3 plus x to the negative 1. So now we are required to work this out. But before we do anything else, let's simplify as much as we can. What this is equal to, well, here I've got negative 6x over 3 plus x, which I'm evaluating between 0.2 and 0.4. And here I've got the negative and the negative, which give a positive. So I've got positive, the integral from 0.2 to 0.4 of 6 over 3 plus x with respect to x. So this term remains the same. And integrating 6 over 3 plus x, I end up with 6 times the natural log of 3 plus x, which is being evaluated from 0.2 to 0.4. And I can combine this into a single evaluation. We've got negative 6x over 3 plus x plus 6 times the natural log of 3 plus x between 0.2 and 0.4. Now if I substitute in 0.4, Well, I've got negative 6 times 0.4 over 3 plus 0.4. That's negative 12 over 17. And I add on to this 6 times the natural log of 3 plus 0.4, which is 17 over 5. And then I subtract from this. Well, if I substitute in 0.2, I've got negative 6 times 0.2 over 3 plus 0.2 plus 6 times the natural log of 3 plus 0.2. So I've got negative 3/8 plus 6 times the natural log of 16 over 5. So I've got negative 12 over 17, subtract negative 3 over 8, which is negative 45 over 136. Then I've got 6 times the natural log of 17 over 5, subtract 6 times the natural log of 16 over 5. So I've got 6 times the natural log of 17 over 16, which is what my integral is equal to. Question number 14, part A, we have to show that the equation 2 tan theta multiplied by 8 cos theta plus 23 sine squared theta equals 8 sine 2 theta multiplied by 1 plus tan squared theta may be written as sine 2 theta multiplied by a cos squared theta plus b cos theta plus c equals 0, where a, b and c are constants to be found. So for part A, we begin with our given equation as we see here. Now I'm going to rearrange so that one of the sides is equal to 0. So I begin with this 8 sine 2 theta multiplied by 1 plus tan squared theta, and I'm going to subtract from this 2 tan theta multiplied by 8 cos theta plus 23 sine squared theta. So we have 8 sine 2 theta multiplied by 1 plus tan squared theta, and if I multiply out what we have here, we subtract 16 tan theta multiplied by cos theta, then we have negative 46 tan theta sine squared theta, and this is equal to 0. So we have 8 sine 2 theta, and then the 1 plus tan squared theta can be replaced with sec squared theta, and then we subtract 16 multiplied by tan theta, which is the same as sine theta over cos theta, multiplied by cos theta, and then we subtract from this 46 multiplied by tan theta, which is the same as sine theta over cos theta. Then I multiply this by sine squared theta, and this is equal to 0. So I've got 8 sine 2 theta multiplied by sec squared theta, which is the same as 1 over cos squared theta. Then I subtract from this 16 multiplied by sine theta over cos theta multiplied by cos theta, subtract 46 multiplied by sine theta over cos theta multiplied by sine squared theta, and this is equal to 0. So we have 8 sine 2 theta multiplied by 1 over cos squared theta, subtract 16 multiplied by sine theta, because the cos theta is simplified to give 1. Then I subtract 46 multiplied by sine theta over cos theta multiplied by sine squared theta, and this is equal to 0. So I have 8 sine 2 theta, and if I multiply through by cos squared theta, I end up with negative 16 sine theta cos squared theta, and then we have negative 46 sine theta cos theta sine squared theta, and this is equal to 0. So we have 8 sine 2 theta, subtract 16 multiplied by sine theta multiplied by cos squared theta, subtract 46 multiplied by sine theta multiplied by cos theta, and the sine squared I'm going to replace with 1 minus cos squared. Ultimately, what we want to do is end up with something involving a sine 2 theta, and then we want a quadratic in cos only. So we have 8 sine 2 theta, then this term I'm going to write as 8 multiplied by 2 sine theta cos theta, and I multiply this by cos theta, because the cos theta and the cos theta give cos squared theta. The 8 times the 2 gives the 16, and we still have this sine theta. And similarly, for this term here, we have negative 23 times by 2 sine theta cos theta, which is the same as 46 sine theta cos theta, being multiplied by 1 minus cos squared theta, and this is equal to 0. So I have 8 sine 2 theta, subtract. Now here I'm got 8 times by cos theta multiplied by sine 2 theta, subtract 23 multiplied by sine 2 theta multiplied by 1 minus cos squared theta, and this is equal to 0, recognizing that 2 sine theta cos theta is the same as sine 2 theta. So if I factorize out a sine 2 theta, then we have inside the bracket 8, because 8 times by sine 2 theta gives 8 sine 2 theta, and then I subtract from this 8 cos theta, because negative 8 cos theta times sine 2 theta gives this term here, and then I subtract 23 multiplied by 1 minus cos squared theta, which gives this term here, and this is all equal to 0. Now this term is a quadratic involving cos squared only, and I've got this sine 2 theta outside the bracket, which is almost what we want to show. So I've got the sine 2 theta, and if I tidy up this bracket, I have 23 multiplied by cos squared theta, subtract 8 cos theta, subtract 15, and this is equal to 0. So A is 23, B is negative 8, and C is negative 15. Part B, hence solve for x being in between 360 and 540 degrees, 2 tan x multiplied by 8 cos x plus 23 sine squared x equals 8 multiplied by sine 2x multiplied by 1 plus tan squared x, where x is a real number and x doesn't equal 450 degrees. Now clearly what we have to do is use part A. The x has been replaced as appropriately, so we need to use this result here. But instead of us having a theta, we would have an x instead. So for part B, we'd have the equation sine 2x multiplied by 23 cos squared x, subtract 18 cos x, subtract 15 equals 0. Now if I take a look at the sine 2x equaling 0 as a solution, remember we're solving between 360 and 540 degrees, we are required to solve this equation. So the first thing I need to do is change my domain. Here I've got an x, I want a 2x, so my new domain will be between 720 and 1080. So I've got 2x equals the inverse sine of 0, which is 0. Then my next solution is 180 subtract 0, which is just 180. Now we need the solutions between 720 and 1080, so if I do 0 plus 360, I get 360, and if I do 1080 plus 360, I get 540. If I do 360 plus another 360, I get 720. 540 plus 360 is 900. 720 plus 360 is 1080, and if I do 900 plus 360, I get something bigger than the 1080. So now, solving for x, by dividing through by 2, x is equal to 0 divided by 2, which is 0, 1080 divided by 2, which is 90, 360 divided by 2, which is 180, 540 divided by 2, which is 270, 720 divided by 2, which is 360, and 100 divided by 2, which is 450, and 1080 divided by 2, which is 540. If I now take a look at the 23 cos squared x, subtract 8 cos x, subtract 15 equals 0, then what I can do is solve this equation. I can factorize this as 23 cos x plus 15 multiplied by cos x minus 1, and this is equal to 0. So I've got cos x equals negative 15 over 23. Let's try to solve for x. I've got the inverse cosine of negative 15 over 23. So I get 130, and if I do 360 minus this, I get 229. Now remember, I want my solution to be in between 360 and 540. So if I take this first solution and add 360 to it, I get x equals 490.7. I've also got cos x equals 1, which means x is equal to 360. Question number 15. A student attempts to answer the following question. Given that x is an obtuse angle, use algebra to prove by contradiction that sin x subtract cos x is greater than or equal to 1. The student starts the proof with, assume that sin x subtract cos x is less than 1 when x is an obtuse angle. They've then squared, leaving them with sin x subtract cos x squared is less than 1. The start of the student's proof is reprinted below, and we have to complete the proof. To begin with, we've got the graph of sin x shown in red, and the graph of cos x shown in blue, in between 0 and 2 pi. Now, for obtuse angles, those are angles between pi over 2 and pi. Well, you see here that sin x is greater than 0, and you see here that cos x is less than 0. Bear this in mind. So, starting off with the line, assume that sin x subtract cos x is less than 1 when x is obtuse. Now, the reason we start off with this particular line, if we think about what we want to show, we have sin x subtract cos x being greater than or equal to 1. We want to prove something by contradiction, so we start off with an assumption that is opposite to this, which is why we assume that sin x subtract cos x is less than 1 when x is obtuse. And if we square, as the student did, we have sin x subtract cos x squared is less than 1. And just as a quick note, sin x subtract cos x is greater than 0 for obtuse angles. That's because sin x is greater than 0 and cos x is less than 0. So we have something positive subtract something negative, which is positive, and this is for the obtuse angles. So, if we square, well, we've got the sine squared x, subtract 2 sin x cos x, then we add on cos squared x, and this is less than 1. So, sine squared x plus cos squared x is 1. Then we subtract 2 sin x cos x, and the result of this is 1. So, the one on the left and the one on the right simplify to 0, leaving us with negative 2 sin x cos x is less than 0. Now recall that sin x is greater than 0 and cos x is less than 0 for obtuse angles. So, we have this negative 2 multiplied by the sin x, which is positive, multiplied by the cos x, which is negative. So we've got negative 2 times by something positive times by something negative, which is positive. Which means negative 2 sin x cos x is greater than 0. But this is clearly a contradiction to what we said here, which means because we've got a contradiction, the original statement is true, whereby sin x subtract cos x is greater than or equal to 1.